It's too loud. Thank you very much, Jared. Okay. If you're standing in the back and you're not supposed to be in the GROW meeting, you could go outside and help us out. If you're standing in the back and you're supposed to be in the GROW meeting, perhaps you could sit down. Hello, you in the back. Thank you. Goodbye, Alvaro. All right, as I was saying, this is the GROW meeting at IETF 105. If you're not supposed to be in here, you could stay. It might be fun, or you could go to your meeting you're supposed to be at. If you're presenting, you should definitely either stand at the mic and speak into it like this, or hold the mic. But please don't do this because no one can hear you. Okay, now those presenting have a little clicker. It has a forward and a reverse. It also has a pointy at the screen thing. Okay, there's a thing in front of you, so you don't have to turn this way and stare at the screen. All of that out of the way. We have a note well. I'll wait while you read it. Okay. There's a bunch of resources online, the Jabbers thing, all the meeting materials that are going to be presented are already posted online, so you can grab those and look at them at your own leisure. There's a Jabber room where Natalie is hopefully scribing for us. We'll need a notes taker. Warren Kumari. Oh, okay. Restrictions. Anybody else? Okay. Jared's going to do some notes for us. Good. Now we move on. Okay. I see you found your pairing. All right. There's blue sheets. They're going around. Please be sure to sign them so we can get a room this size or larger next time. We have a minutes taker, a Jabber scribe. We're going to do some agenda bashing. Really just going to show you the agenda. Stuff about existing drafts. We have some things. This is, I think, all up to date, actually, even. We hope. Okay. Couple of things in IESG review are headed that direction. There's a question about whether we should adopt something or not. I think that might not actually have been sent out yet. If you have a draft and you're wondering, gosh, is somebody going to do something about this? My draft, it's so cool. You should let the chairs know or ask on list for what you think is the next step. Either if it's not adopted, ask for it to be adopted. If it's currently got a bunch of comments and you've dealt with all those and now you're ready to push it forward, please let us know to send it for working group last call. Asking often is probably fine. Joe, do you want to say something about the IDR recharter?
Yes. Our brethren at the IDR working group are looking for input in context of a new charter. So if we as operational community have feedback as to what the BGP protocol should look like on the wire and in its behaviors, now is a great time to review those email threads and provide your input to IDR. So please take that under advisement. I don't know when the chartering process will stop, but I expect that if you give feedback in the next 1 or 2 weeks, it can be taken into consideration.
John Scudder, IDR co-chair. Yes, thank you. And we will be talking about this in our Friday meeting. So welcome to show up at that and put in your 2 cents. Yes, in the next few weeks would be a really good time to provide input. And just to briefly reiterate what Alvaro said at our meeting that just concluded, you know, our desire is to keep the sort of overall charter statement relatively broad and to track nitty-gritty details in the milestones. So we're very glad to take in nitty-gritty details, but they're likely to end up in the milestones portion and not in the charter proper. Thanks.
Thank you, John. Then a small update on, then a question from the Jabber chat room.
Yeah, question from Illich from Bijnen. And he asks, where is the guidance on which IDR-related topics go where?
The IDR topics go to the IDR working group.
John Scudder again. That is exactly what the IDR chairs were talking with the ADs about this morning, and I think it will be relevant to the IDR charter discussion. So yes, we hope to have more guidance of that nature that appears in the IDR charter and possibly in the charters of related working groups.
Thank you. A small update on evolving documents or living documents. At the last IETF, we spoke briefly about the concept of a faster publication mechanism to bring operational guidance faster to the various stakeholders and users of the BGP protocol. The IESG currently is reviewing this concept and coming up with proposals. Tonight in the IETF plenary, there will be an update from Warren Komari on this topic. And tomorrow morning at 8:30. What? You showed me slides. Was that not for tonight?
No. Those slides are for tomorrow. I'm not opening that kind of worms there. No, there's not going to be an update tonight. Or if there is, it's the first I've heard about it.
There will not be an update tonight. But tomorrow morning at 8:30 in this very room, Duluth, there is a gathering to discuss the concept of documents that are not RFCs. And I think that would be interesting to the operational community to have such a tool. So if you're agreeing with that, please come to the site meeting tomorrow morning and provide your feedback on these ideas. More mic? My apologies. So tomorrow morning, 8:30, this room will talk about living documents or evolving documents or whatever it's called tomorrow morning. All right, we can start with the presentations. I would like to invite Alex to talk about leak detection and mitigation. Thank you.
Hello, everyone. My name, again, is Alexander Azimov. I work for Yandex. And now, without hush, I would like to discuss with you route leak mitigation solutions. For those who was not at the IDR, I will just recap the most crucial points. So, previously, we had two types of signals for route leak prevention and another signal for route leak detection. The first rule says, if route is received from provider, route server, or peer, it must not be sent to another provider or peer. So the only direction that is applicable is customer. So you may send your prefixes only to customers. The second rule, if route is sent to customer, peer, or route server client, it also must follow only done rule. In other words, again, it must be may be sent only to customers. So these rules are fully compatible. One is working on egress, the other one is working on egress. So, yeah, I understand. So yeah, I also hear noise from outside. Yeah, I will. This is good. Okay, I'll try to do it this way. So we decided to make it a joint signal, and more than we will have two signals. There was an argument about which one is better, attribute or community. Attribute has a lot of advantages. It's more reliable, it's memory efficient, it has a resolve to use. But the community can be deployed tomorrow or a day after tomorrow. So we would like to have advantages of both approaches. We will have community tomorrow and attribute the day after tomorrow, maybe later. So here is the specification for a community that nearly models OTC behavior that I presented at the IDEA working group. So we suggest to reserve this class for well-known transit communities. So these communities should not be stripped on egress. So the first one is just subclass for do community, and the value is carried is the autonomous system number. How this value is set? Like in OTC, on egress, if you are sending it from provider, peer, or internet exchange route server, you are setting it with value of your autonomous system number. On receiver, if you are customer or peer, you are also setting it with this number. So it doesn't matter if it's a set on egress or ingress, the value will be just the same. It works nearly the same like OTC. So as we discussed, in this example, we have provider on left side, IS2 is taking transit from its provider. It also has a peer on the right-hand side. The signal in this particular example community is set, maybe set on ingress, maybe set on egress. It doesn't matter. The value will be the same. So when it goes through the network, to prevent network from leaking, it just need to match the class of the community. The only difference from EOTC happening, not EOTC, OTC happening on egress at the level of IS3. Imagine that IS2 is not filtering, and so it's a leaker. Unfortunately, we are not able with community match, in a single community match, create a rule that says a match for class and doesn't match for value. So this rule must be transformed into two matches. First, check that IS2 is not setting the community. Second, check the class. So it is based on the assumption that if IS2 is adding marking, it also makes filtering. It's very important, and we'll get back to this filtering rule. So the most important question, what we should do if we detect a root leak. So there are three common options. We should drop it. We should set a local pref to 0, or just let it go. So drop it is clear. I will not describe it in detail. Let's move to the second option, local pref 0. The previous versions of the draft suggest this kind of behavior. And the idea was that maybe there is a customer that has only single path from originator to a tier 1. And if route leak happens in this path and immediate upper provider accepts it, and then next level provider detects it and drop it, we may end up that route leak results in connectivity loss for the victim. And for this case, we thought that local preference 0 can solve the problem for in this unreliable topology. But it has very important side effects. So first, going to side effects, just see the number of actions that must happen at the same time to make network unreachable. So it's not very likely situation. So let's go to the side effects. First one happens because of when root leak is propagating through the upstream providers, they're still able to detect it. But when such prefix goes down, the network loses opportunity to say if it was a route leak or not. So it may become more preferable. We are getting in a situation with priority loops, BGP wages, and in some specific topologies, even stable BGP oscillations with dynamic BGP loops. So it's not tasty. This situation can be fixed with additional signal. But even with additional signal that says, for example, we detected a route leak, we cannot guarantee for this customer with unreliable topology that prefix will become reachable, because it will depend on the policy of other parties. You are saying, I'm propagating a route leak. Many providers will just drop it. Okay, but it's not the full problem. The biggest problem is prefixes that has a specified policy that restricts its propagation. It might be done in different ways. It may be because I'm using some control community to limit the ways prefixes is propagated by my upstream provider. Thank you, Ben. It may be a more specific prefix that is sent only through Internet Exchange Point. So there are many kinds of such policy when prefix becomes partially visible. And from receiver side, you are not capable to say if the leaked prefix that is received from your customer is poor indirect customer with unreliable topology, or if it's a CDN that had such policy, it's advertising more specific, and you are going to ruin its connectivity plus ruin your own connectivity to the CDN. So this is just a highlight. I made this calculation yesterday, and it shows the number of prefixes and its visibility. It's based on RIPRI's data source, all small prefixes that has length more than 24 are ignored. So you see, the number of affected prefixes is really high. So the only safe way to mitigate route leaks is to drop them. All other ways like local preference 0 or anything else will result that you will create a hole in the security solution, and one day you will shoot your own leg with it. The only exception may happen when, at the time of early adoption, one may want to see the signal before making a decision that we are ready to implement drop policy. It can be done, but with caution. As we discussed previously, if we see marking from a neighbor autonomous system number, we have an assumption that it's have drop policy. Otherwise, we are losing the signal. So if you're going to do only marking, you should go, follow these limitations. They will be described in the next version of the draft. So here's the result. The only opportunity to mitigate route leaks is to drop them. You should follow this rule. The only option is just to pass it by, but you're accepting route leaks. You may send your egress traffic to a black hole. What are the next steps? We really need your feedback. We finally got consensus among the authors, and the version that is in mailing list with the minor changes will be uploaded into the tracker. I hope that I will be able to do it during this week. We also will require IANA allocations for class that will say that we have well-known transit communities plus a subclass for leak detection, prevention, and so on. And we really need to go forward to have a fast working group last call, because if we will wait for years, there will be no reason for this solution, because we will have a more reliable OTC or ASP in place. So thank you for listening.
Speaking as a, I don't know what, but I would recommend you to not refer to values that have not been assigned, but put in TBD, to be determined.
Okay. Valid point, thank you. But I just like this number.
A lot of people like that number. That's
Yeah. I understand.
Jeff has, and you made one of my 2 points. Second point is that large communities were, for various reasons, designed to not have reserved values. So one of the things you need to be aware of is that regardless of what working group this happens and you're about to make a operational change and having IATA carve out a piece and, sort of like the well-known stuff for, 1997 ones, you want vendors to eventually have magic behaviors for those. Think about this step a little bit more widely and coordinate with IDR about what happens with large communities, whether you would actually carve out a range of values similar to what's in 1997.
Okay, Jeff, thank you for your comment. Before asking the next question, just so from the point of process, so where should we request the class to be resolved from the IANA? In this draft, or it should be another work? Because we need a subclass, of course.
In a different draft, which coincidentally is on the to-do list of the chairs of this working group, we can instantiate a registry, and that draft will allow us to discuss the concept of a registry and see if IDR and GROW agree that there should be a registry. And once that registry exists, then your draft can just request a value from that registry.
So may I ask the chairs of the working group to move forward with this work?
Come on, Chris. Yes.
Good.
Thank you for your feedback.
Can you back up? I think it's one slide back. I think what we agreed was that the wording is that the default mitigation policy should be must reject and that you should follow the default. Otherwise, I don't know what it means to say the only acceptable policy is.
You see, it's very important wording. The only acceptable mitigation policy. The only acceptable mitigation policy. It's not. It's not.
Something else isn't a mitigation policy.
Yes. So when you're doing only marking, you are not doing mitigation.
Yeah, it's word brain surgery or something.
Okay,
let's try to be a little bit more clear about it.
Okay.
Ben Madison, Work Online. Yeah, I found that confusing, but I was just about able to pass it. My understanding reading that is that the only thing that is mitigation is rejecting, and you may or may not choose to mitigate.
Yes, it's correct.
I prefer that construction to having a recommended default. I don't think anything other than dropping leaks is mitigation. And dressing something else up as mitigation is counterproductive. And I think we saw that in origin validation for years.
Okay, Ben, thank you for the comment, because I fully in line with you. Any other questions, comments? It seems that we are happy. Good.
Thank you for your time. Who is next? I think you're next.
No. Yes. No. 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 That's the next one.
Oh, you want to do this one instead?
No, that's not mine. This is the one. Yes. All right. There is no box here. Yeah, it's the.
Yeah, perfect.
Fantastic. So I am Paolo, and finally I have only one slide for 2 drafts. So I hope we are on the right path. So I would like, first of all, to present around lock rib and edge rebound. More, yes, perfect. And so this is the only slide that I have on these two drafts, right? We presented in 2017. There is a lot of backup slides in this presentation on the motivation why we are doing this and things like that. The key takeaway is that we are adding important vantage points over the existing RFC of BMP. So in the existing RFC, we have edge ribbing pre and post policies. We are adding lock rib and edge rebound pre and post policies. Since the last IETF, only minor changes, right? Edge rebound is in IESG review, and feedback was processed and things like that. I think things are going well. And for lock rib, which is the one that is slightly more active, we did process the feedback of Jeff Haas. Thanks, Jeff, very much for the feedback. He had plenty of feedback. Now, if you grab through the document, there is no fib wording anymore. That is maybe one of the most important things, plus many other things. And while I was processing his feedback, I catch something else, that we have TLV about VRF and table name. And table name is, for example, if you have a slice, a partition, a specific view that you are passing of the lock rib, and VRF, it's VRF, right? And so it's possible that you want to have this TLV repeated multiple times. I catched it while I was processing his feedback, so some text was added to it. And that is pretty much it, right? Now, if you remember last time at IETF104, there was quite some queue of people, asking questions around, what goes in lock rib, active routes, all routes, installed routes, and things like that, right? And it is true, this draft is maybe a little bit determines a little bit what goes in lock rib, but any question that you would still have around that, I ask you if you can hold your tongue for the next presentation, where there will be Camillo here, because it's maybe the most proper presentation to document where to ask this about BMP path marking. So any questions, anything? Can I go to the next presentation?
You may.
Sure. Can I get the next presentation?
Let's hope we can find it. No.
No. No. Yes. Cool. So the second presentation I wanted to, draft I wanted to speak is this draft about TLVs. The original title, and it's something that I am doing myself with Yungang and Hank. Hank is remote. Hey, Hank, we love you so much. So the original title of the presentation was the title of the draft, but the other day I was given a lesson about how in the intent-based things era, we should focus also IETF documents on intents. So the real title is Future-Proofing BMP. Thank you, Jeff, again for the suggestion. So a little bit of background or history behind this draft is that if you remember, like 1 year ago, Hank, he presented, he wrote a document about how to make BMP more extensible. I myself was a supporter of that draft, and also we met in person with Hank, and this is an interop meeting between me and Hank in which he was exporting from a Nokia device BMP content with following that draft, and I was collecting it with PMSCCT, and we were super duper happy because everything worked. But then what we did is a little bit of an exercise about rereading the draft and things like that, because it was quite extensive draft, right? And so we could do this exercise and dissect it in 3 main areas that the draft was touching upon. And so one was very easy. It was getting into use cases, and we should, it's not the greatest idea to compound use cases with other stuff. And so it was good to leave the use cases alone. And then it was touching upon 2 other areas, very important. One, the TLVs, introducing TLVs in BMP. Not introducing, but making sure that all the messages have TLVs. And review message types, right? And so we are here, right? So in the TLVs, so this draft essentially wants to be a little bit a child of that draft that only addresses the TLVs. And why we wanted to split the TLVs from a review of the message types, so where you see we have an idea to have draft in future about that, is because, it's 2 different beasts, right? So the TLVs are, if you pass me the term, more important for a business perspective, right? So to make more critical mass around the protocol BMP, because with that you can pass more information, more metadata, vendor-specific data, and things like that. So enables further applications around the BMP. And on one hand, you can also say, so it's very important, and in a way, TLVs are it's a very simple concept, right? So having TLVs appended to BMP messages. We will see that there are some perils also there, but we can say it's easy. The reviewing the message types is more a beautiful engineering effort, which is slightly more complex, because we can have all different ideas on how we want to beautify the protocol and things like that. But we can kind of say that it's an engineering effort more than something with the business critical sense, right? And so that's why I think they really belong to 2 different drafts, and so we went to separating the 2 things. That said, what is the problem statement? The problem statement is simply, it's like we have a table with 4 legs, but not all the 4 legs are the same length, right? And then, not all BMP messages do support TLVs, right? So very importantly, the root monitoring messages, maybe the most critical one, doesn't support the TLVs. And also, the peer down message doesn't support the TLV. So what is the ideas in the draft is to add TLV, not add, simply allow for trailing TLV data in the BMP messages. And in order to do that, and I leave it as the last point here, like bump the version of BMP to 4, essentially. I want to leave it as last because, I want really to stress that that is not really the key part, right? So we are not in a critical point, we are not inventing a whole new protocol or anything like that. It's really just backward compatibility. So that said, there is one open question. In the first release of the draft, it was on purpose left underspecified how to handle the peer down, right? So it's just written that also the peer down should have TLV data. But the truth is that you have 3 code points that allow for trailing data, and this data is not necessarily in a TLV format. There are other code points that, it's not specified, that they can have trailing data and things like that. So again, even there you have not an even surface, and solutions for that could be anything, right? So from the most extreme, like we have a new message type, to we duplicate the code points, to we say we have in BMP4, and so now the trailing data should be in TLV format, to anything, right? So there are multiple solutions to this problem. I would maybe prefer something that is low impact from implementation perspective, but feedback is appreciated. So anybody has ideas or preferences or whatever, please let me or us know. Working group adoption, is there any interest? Yes? Oh, thank you.
Please send a message to the list asking for adoption.
Sure, I will. And I hope we have an exit 0. That's it.
Thank you for your time.
Yeah. Thank you. Questions? No question, no comments?
We shall move it to the mailing list.
Fantastic.
I want that toy back. Or
thank you. How does this work? Oh, yeah, I see. Let me see how I handle this better.
Flip it around.
Oh,
There you go.
fantastic. Hey, so, hello, so I'm Camilo from Entity. So I would like to present this draft on BMP path marking. So the goal of this draft is basically to mark the paths in BMP with their state on the local RIP. If we have this information, maybe we can allow some different applications. I know, so that means basically that if you can get the path mark as if it's installed in the RIP, if it's a backup path, if it's hopefully unresolved maybe, and stuff like that. We are open for suggestions on what else to mark. Uses the TLB mechanism that Paolo Lucente just presented. So there's some phase sharing there. This is actually a rehash of a very old draft. So like around 8 years ago or 7, whatever, or 6. We had idea of, of using that path and communities to actually mark. So using that path to get all the paths from a router and then using communities to mark what type of path they were, if they were best or best external or stuff like that. However, even though technically there was not much of an issue, like philosophically it's not such a good idea, at least in the mind of many, to monitor BGP with BGP, but use the BMP, which back then was not very mature. Now it seems to be, so why not to put it there? So it's a TLB. Basically, right now we have, so this is the basic idea. The rest is our, I mean, we have the first iteration over this. Maybe we will probably improve it in the future if it's interesting or not for the group. So right now we have the path type and a reason string, because why not? So the type is actually a bit field, so you can have more than one type for a specific path. I mean, here are some initial ideas of this. So you can mark like the path is best path or primary, which basically means that if you have multipath, then you can have multiple paths on the install for forwarding. We took that terminology from the PIC draft. You can mark whether a path is a backup. So for instance, if you don't want to run a very complex BGP simulator and you have this information, then you can use that for that application. Then you can also have, for instance, unreachable next hop. So you can say that a path is invalid. Last week, actually, Alvaro Retana sent on the IDR that we really were not sure what unreachable next hop meant, but I mean, whatever. So there's still best external path there, which after 6 years is still a draft, even though people use it. I don't really have an application for that, at least for optimization, but maybe if you have this information, you can verify your network, or, I mean, the more information, the better, I think, at some point. There's also a reason string, because why not? So the idea here is that if the platform actually allows you to tell why a path is in a particular state, for instance, why it wasn't the best, or why it's not installed, or why it's unreachable. Maybe the next hop is a multipath, is a multicast address, or maybe you had a cap in the number of backup paths, so maybe you can write that in the reason string. This tends to be controversial, I think, this type of reason strings, but parameterizing this information might be very complicated. and it could be useful for debugging purposes. So again, this is the structure we have now. We're open for suggestions. And that's it for that side. So I do have an open question, which is what Paolo mentioned before, which is what relationship will this have, for instance, with the local RIP and the other RIP drafts? So I believe this is this basically comes from the local RIP, but to actually have a rich information, then we also need the invalid paths. And I don't know if the local RIP draft allows for that or not. I don't know if it's explicit or implicit. So that's my open question. And that's it for me. So we can go to Jared.
Jared Mach, Akamai. Can you go back a couple slides to the reason codes? Or back another one, I think. Yeah, this one. So I'm just curious where this registry would live. Because this seems like it's more of like a protocol level message here, and I'm wondering if this would live in GROW or in IDR or somewhere else.
Registries live with IANA.
Yes, but who's an expert with IDR?
Jared's point is that it's a protocol generic type behavior. These things can be covered by multiple things elsewhere in BGP. So rather than define them, once for this application, should they be used for other thingies? Probably not, but that's his question.
Thank you for the clarification.
Jeff has, so Camilo and I have had this conversation, this part of this conversation already before, so this is partially for the room. I like the idea in general. This is overlapping, some other questions, including the person that was just up at the mic had about, do we have some way of maybe tracing, did this route actually made it through the install process, intelligible for route selection, that sort of thing. Rudiger's had similar comments before as well. The problem with a lot of the things in this set of states is many BGP pipelines and the implementations are not fully synchronous. You get a route, and it may go through several stages before you actually get some of these things potentially set. Like reachability of next hop may come very late in the route install process. Whether things eligible for multipath is another example. So, and whether or not something's elected for best path, some people have route selection happen very far down their pipeline. And the problem with this is the original BMP ribbon, at least, it's a very dumb feature. You can just stream this stuff out almost immediately if you want to, if your implementation wants to allow it, or come very late. Trying to actually tie these things in is trying to actually lock the implementation down to don't send anything out until some of this stuff is determined. And I think you might find that actually has bad impacts on some of the use cases ribbons used for today. So,
and one question, Jeff. And the local RIP, for instance, implementation is not also affected by that?
Local RIP is actually far worse. So
okay.
if we want to pick like RIP-in cases that are good, so best path, you're not going to know that by that point. Knowing that it's installable, a lot of people's policy engine will get to that very quickly, and that's something that's easy to pass back on the BMP message. Reachability may vary, and some of these things like these set of flags, if you're actually getting these as part of your local RIP feed, local RIP is only giving you the active route, because giving all the state as it changes through the set of routes that are getting altered as part of route selection, changes, resolution state, policy, whatever, you'd end up with just nothing but this endless churn of these bits if you actually expose them that way. So I guess my two pieces of advice are, some of these things may have negative impact on the implementation if you really care about them. And the second thing is, in a local RIP context, you'll end up with a sea of churn that really doesn't give you potentially a lot of useful information. But if you advance back to the string slide, the second piece of feedback here is that this stuff is interesting. It overlaps the work that Yunan's doing for Tencent. And I think there's some value out of having that conversation continue in relation to that. But the related piece of feedback that sort of goes into, should we put this state into BMP? We talked about this in IETF104. BMP is a difficult place to put this stuff in because you're sort of jamming up the pipeline with more and more information. BMP is already pushing the fire hose of information down a drinking straw. So the problem we have here is that strings are useful. They don't compress terribly nicely in the protocol, and this sort of just fattens up the PDUs with information if you send this with every single thing. Might be interesting, but you probably want it as a telemetry feed for interesting things rather than as a continuous stream.
Ben Madison, work online again. I suspect Jeff is going to have an opinion on this as well. So at least one implementation of AdParse that we run has this concept of marking routes as members of a set of eligible prefixes that can be advertised to an AdParse capable peer. And this fits in quite well with your set semantics for the types, because those are, those can be entirely disjoint or they can be entirely overlapping. And I can see a use case for us where, in order to evaluate whether or not we want to be sending some larger or smaller set of prefixes to a given neighbor, we want to be able to get an indication of what the additional memory consumption is. And this potentially gives us that very easily if we're able to stick those set memberships in that code set. But as I say, I suspect Jeff is not going to love that.
Thank you.
Hello, Alex and Asimov, Yandex. So I can say that I was following all BMP drafts. It's my fault, but I have a question. So we have a growing number of security solutions. We have route origin validation. We may have ASPA and other stuff that affect BGP decision process. Am I right that with these recent stream, I will be able to say that the prefix was not accepted because of APK validation or because of root leak was detected?
I don't see why not. I mean, that's why we left it open. But as long as the information, as Jeff was saying, it might be complicated, but that was one of the. This one, the idea here is that all paths enriched with information of the log trip. So after the decision process is made, if that decision was made after the decision process, I don't see why not. Obviously, on my paper, me doing the paper, I don't do the code, so I obviously could think that is hard for do, but I don't see why not. For instance, if something is very important, maybe we can also add a type for it. But obviously, with this struggle of implementation versus what we need, so what we as customers of devices of route monitoring need versus how hard it is.
Just a quick point. There's 12 minutes left and 2 presentations from Yunnan still to go. So, all right, quick. Make it quick. Okay. We can always talk about this on list too, of course, right? Okay.
Thank you very much.
Thank you. It's your turn.
Which one do you want to do first? This one or the other one?
The root leak detection one.
Okay, that's this one.
Yeah, thanks for saving me several minutes. And can you hear me clearly? Yes. Okay. So I'll do a very quick update on this draft. And this one was previously presented once on IETF 103 that we use BMP to carry the root leak detection information. And nothing much has changed in sense since then, but I would like to bring up a major information here is that I want to clarify the position of this draft because there have been several works that Alex has been working on to do root leak, either prevention, detection, or mitigation. So our draft stands here for root leak detection, and The difference between my draft and other works is that the detection of root leak happens exactly at the local AS. As far as I understand, and after I have also discussed with Alex, there has no method that can be used to detect the existence of root leaks that is happening at the local AS. Okay, so typically leaks can be detected in the upstream or downstream ASs, but not in the local AS. Okay, so that's where this draft stands. Okay, and very simple example. Very simple idea for this draft that we want to use a ILD-TLV to carry the business relationship. To state what's the current relations, and then at the BMP server side, it can combine the ILD-TLVs from the ingress and egress nodes, and then combining to analyze these two relationships to detect if any root leak has actually happened within the AS. So very simple idea. Any questions on this draft? No, let's move forward to the next draft. Okay, so in this draft, we use BMP to record and trace the BGP root policy processing. And thanks for the working group's comments and inputs since last IETF. And we have actually made a lot of changes to the previous version. And but today, I will first show you the current position of this draft, and more importantly, I would like to get more inputs from the working group how this draft should go, because after I have been talking to some of you like Jeff and Rudiger, there still exists some gaps with respect to certain perspectives. So yeah, I would like to see how the working group suggests the draft to go. And a quick recap of the idea. So this draft what it does is that it records the processing of a root policy, and this is an example that shows you what is exactly recorded using this proposal. So here we have the prefix 10.1.1.0/24. It is received from a BGP peer 192.168.1.1. And then it goes through the inbound root policy, which is called root policy CAP, and with the node ID or item ID 100 at time T1. And an action was applied, which is adding a community to the prefix. Okay, so what can we do with such data? Here we list several use cases. First, it can be used to do root policy validation. For example, you configured a new policy to do maybe root leak prevention. So you add new filtering conditions, and then you can use this function to record if the prefixes that you care about are actually correctly filtered or not. Okay, and also it can be used to do root cause analysis. So the root cause analysis is not used right after the policy is configured. It is actually used after a certain period of time when the policy was configured, because some of the issues are only triggered when certain environment conditions change, so that you don't know when the what what policy is actually responsible for the current issue. So you need to have such record within the device and then to locate the actual root cause. Okay, and third example is the root propagation trace, and there's one example in the draft that tells you how you can do that with the data recorded. Okay, so here I list the three major changes from the first version. The first one is that we designed a new message structure, which consists of two parts. Which first one is the basic information part, which is fixed length, and it tells you the basic background information about the event. And then the second part is flexible. It can be customized according to user requirements, either it's bandwidth consideration or your visualization requirements. Okay, and the second change we made is that we designed a new structure to represent the root policy, basically to allow the policy chaining and policy recursion. And the third thing is that we add a optional TLV to allow users to freely express whatever they want. Okay. So here's the message. The message body looks like. It consists of the prefix information and then the event information. So one thing I would like to mention specifically here is that how we define an event, because previously there have been discussions on how we can use this functionality. Some people has mentioned that it can be used to do programming, execution, tracing, or say debugging. But I thought about it, and I would say this draft is not positioned, should not be positioned in that place. I would say this draft does the tracing at the root policy level. Okay, so that's two things from the actual programming execution. So here the event will be defined as one root policy execution, whether it's mapped or matched or not matched. Okay, so whenever a policy is executed, there is one event generated. And this is what each single event looks like. It consists of majorly four parts. The first part is environment. It tells you the timestamp, event index, and other basic informations. And then we have the second part, which is the event results. It tells you the BGP attributes right before and after the policy execution. So this part is optional. You can have both pre and post policy attributes uploaded, or you can have just one of them, or you can have none of them. Okay. And then the third part is the event course, which is the policy part, which tells you what is responsible for the results. Okay. And according to Rudiger's suggestion, and I also believe that we should exchange the course and the results, the order of these two parts, and I'll do it in the next version. And the last part is the event notes. This is the optional TLV I mentioned just now, and I'll show you in the later slides how we can use that. Okay, so these three, the event results, course, and notes parts are all optional. So the attribute TLVs look like that. So if you have both pre and post policy attributes carried in one message, then you can have a direct one-by-one attribute comparison for before and after policy. The reason that I add the pre-policy attribute here is that because sometimes we miss the recording of certain events. So there are not necessarily a direct relationship between the two events that are reported. So with the pre-policy attributes, you can have a very direct and straightforward visualization of the results before and after the policy execution. Okay. So, and this is a new policy structure that we have defined. Previously, we only allow one policy expressed, but now we add the recursion and chaining consideration here. So basically what we do is that we use a C bit and R bit to indicate the relations of the next policy to the previous one. So you can stack like I would say unlimited, but it doesn't necessarily have to be like that. You can stack policies one after another with relationships indicated with the C and R bits. And there's also one policy match flag, which is called the M bit, to tell you if a policy is actually matched or not. Okay. And finally, we have the policy optional TLV. Here, I'm thinking is that it can be a string type TLV that can be used to freely express whatever the user wants. For example, the user may don't want the attribute TLV or don't want the policy ID TLV that we defined. He only wants maybe a conclusion from the device, and of course, this conclusion is also generated probably from the execution results. But he only wants such a conclusion, so he can use the optional TLV to use to express that. So, yeah, that's one possible usage of the optional TLV. And well, that's that. And so I would like to have some feedbacks and comments from the working group, because previously we mainly have gaps regarding what protocol should be used to carry such information, and also some other suggestions. So if
thank you very much. In the interest of time, I would suggest that feedback is provided through the mailing list, because we've reached the end of our session. We're actually overrunning by 2 minutes. We're missing cookies. Thank you very much for your 2 presentations. I will see you all in Singapore at IETF 106. See you next time. Thank you. Hmm?